Hey guys, so today we're going to be talking about proof by contrapositive. So it's a bit like direct proof, but if you're finding yourself in a situation where you're reaching a dead end in direct proof, it may be easier to take the contrapositive. As you can see, we're given the same statement, if P then Q, but we don't want to use P to prove the statement. Let's take the contraposition. So we know that if P implies Q, this is identical to not Q implies not P. So if we are able to prove this statement also holds. Okay, so this is why we're saying take the contraposition and using not Q, prove not P. Let's go through an example. We want to prove that if n squared is even, then n is also even. We can identify this as our P and this is our Q. So we say n is even, n squared is even. And then we take the negations of both sides. So what is the opposite of an even number? An odd number. So let's say if n is odd, then n squared is odd. If n is odd, we can assume that n is equal to 2 times some integer k plus 1. Okay, so we're assuming that this is true. So let's see what happens if we square both sides. So we can see that this is a perfect square trinomial, so we can use the identity to just expand. So n squared is equal to 4k squared plus 4k plus 1. We can see that there's already a 1 here. So let's try factoring this out because we just want a 2 in front, trying to find the definition of an odd number. And there we go. We found that n squared is able to be represented by 2 times some integer plus 1, which is the definition of an odd number. We implied earlier that k is an integer. If you square an integer, add 2, multiply it under closure, it will still be an integer. So n squared is equal to 2k2 plus 1, where k2 is an integer. And after proving that if n is odd, then n squared is odd, we can assume our first statement that if n squared is even, then n is even. And that's it.